This is Gagan Girotra, IIT Roorkee class of 2000, and I am Calcutta class of 2005. In this People Plus video, let's look at certain questions on time, speed, distance. Now, the first question here says that an airplane covers 2,400 kilometers in 5 hours. If it continues to fly at the same speed, the question is how much distance will it be able to cover in a total of 9 hours? So in this situation, you notice that there are two real situations here. So in the situation one, what is happening is that the plane covers a distance of 2,400 kilometers, right? And it takes the plane 5 hours to cover this distance. In the second situation, we are required to find what is the distance that this plane will cover if it continues to fly at the same speed for 9 hours, right? So if the speed of situation 1 and the speed of situation 2 is same, then we can say that d1 by t1, d1 being the distance in the first situation and t1 being the time taken in the first situation, should be equal to d2 upon t2, right? So in the first situation, 2,400 is the distance covered, time taken is 5 hours. This should be equal to the distance covered in the second situation, which we've assumed as x, divided by 9 hours. So straight away we are able to calculate x equals 2400 multiplied by 9 upon 5, right? Because I've taken this 9 here. So we get 5 times 480 is 2400, right? And 480 times 9 is 0, 2, 7, 9, 4, 36, and 743, right? So the plane will cover 4,320 kilometers in 9 hours if it continues to fly at the same speed. Right, so the second question here says that if a person walks at 14 kilometers per hour instead of 10 kilometers per hour, he would have walked 20 kilometers more in the same time. We have to find the actual distance traveled by him. All right, so if a person, so there are two situations. So the first situation, the man is walking at 14 kilometers per hour. In the second situation, the man is walking at 10 kilometers per hour, right? Now, obviously, when he travels at 10 kilometers per hour, the distance he covers is, let's say, x, which we don't know. But when he walks faster, he's able to travel more, because the time given, it is given that the time given for time taken for both these situations is the same, right? And the question tells us that he's able to walk 20 more kilometers. So this is the distance that he's able to cover. Now, when for two situations time is equal, then we know that d1 by s1 equals d2 by s2, where d1 and d2 are the distances covered and s1 and s2 are the speeds with which the respective distances are covered, right? So 40, the distance in the first case is x plus 20, right? And the speed with which x plus 20 is covered is 14 kilometers per hour. This should be equal to distance covered in the second case and the speed with which this distance is covered. Now let's cross multiply. We get 10 times x plus 200, because I multiplied 10 with this numerator, equals 14x, right? So I'll bring this 10x here and it will be subtracted from 14x. So my left hand side remains 200 and my right hand side becomes 14x minus 10x, which is 4x. So I get x equals 200 divided by 4, which is 50, right? So the original distance that the man covered at 10 kilometers per hour was 50 kilometers. 70 being the distance covered in the second situation when he walks at 14 kmph. Now in this question, let's read this question. It says, by walking at 3/4 of his usual speed, a man reaches office 20 minutes later than usual. What is his usual time? Okay, now while it is a little subtle, but you will notice that in this case we are talking about the man going from his home to office, right? So let's say in the usual situation, the man travels at a speed of s, right? And he takes time t minutes, right? But in the special situation, in the special case, if he walks slow, right, the speed now being 3/4 of his usual speed, if he walks at 3 by 4 s, the time that he takes is 20 minutes more. Why? Because he's reaching 20 minutes late, right? Now obviously the question is subtle about it, but because the man is walking from or traveling from home to office, the distance in both these situations is same, right? So if the distance is same, then we know that s1 t1, the speed and the time respectively in the first situation, should be equal to s2 t2, which is the speed and the time for the second situation. So we get s times t equals 3 by 4s times t plus 20, right? So we take this 4 here, we get 4 times st equals 3 times s into t plus 20. Now what I notice is that s is common, so I'll remove this s. So we get 4t equals 3t plus 3 to the 660, right? So I'll take this 3t here, it'll get subtracted from 4t, I get t on the left hand side equals 60. So the usual time that the man takes from traveling from home to office is 60 minutes. If he slows down his speed to 3/4 of his original speed, or to 75% of his original speed, then he takes 20 more minutes, which is 80 minutes, right? So the answer is time equals 60. So in this question, there are two trains which start at the same time from two stations which are 200 kilometers apart, and they travel in the opposite directions, right, towards the other station, right? And what happens is that they cross each other at a distance of 110 kilometers from one of the stations. The question is, what is the ratio of their speeds? So let me just pictorially represent the situation. Now if, let's say, this 200 kilometer distance, right, is being covered by this train which moves from this end to the other end, and by this train which moves from this end to the other end, and they meet at, let's say, this point, which is 110 kilometers from one of the stations, right? If this is where they cross. Now because these both these trains are starting at the same time, right, that means that the time for this train to reach the rendezvous point or the meeting point is the same as the time taken by this train to reach this point, right? And look at the distances that both these trains have covered. If this train has covered 110 kilometers, then out of the total, right, the other train has covered 200 minus 110, which is 90 kilometers, right? So we come back to the situation where the time travel taken by the two moving bodies is the same, right? Only thing is, we know that this moving body, this moving object has covered 110 kilometers, and this moving object has covered 90 kilometers. So let's call this the speed. Let's assume that the speed of this train is x and the speed of this train is y, right? So in the same time, in the constant time situation, we know that d1 by s1 equals d2 by s2, right? So for this train, d1 is 110 kilometers and the speed is x. For the other train, the distance is 90 and the speed is y, right? And if we need to find out x over y or y over x, whichever, I take x here, cross multiply x here, and bring 90 here. So this equation will give me, by alternando, yeah, this will give me 110 remains here and 90 comes to the denominator and x goes to the numerator. We cancel out the zeros and we get the ratio of the speeds as excuse me, the ratio of the speeds as 11:9. So I mark A as the answer. Now let's read this question. It says A and B travel the same distance at the speed of 8 kilometers per hour and 12 kilometers per hour respectively. So A covers whatever distance at 8 kmph and B covers the same distance at 12 kmph. If A takes 1 hour 30 minutes longer than B to cover this distance, we have to find what this distance is. Okay. Now this is clearly for two people to be moving, right? For two different situations, situation A and situation B, basically the distance is same, right? Now if A, let's look at how A's situation pans out. So A is covering whatever distance, right, at 8 kilometers per hour, right? And let's say A takes we'll come to the time here. Let's look at B situation. So B is covering the same distance at 12 kilometers per hour. Now if you notice that one of them, A, is taking 1.5 hours longer than the time that B takes, right? So if let's say I assume that B takes time T to cover this distance, then A is taking T plus 1.5, right? Now why I have taken 1.5 is because 1 hour 30 minutes, when I convert the whole thing into hours, becomes 1.5 hours, right? And I must have hours. Why? Because the speed is in kilometers per hour, right? So even the distance will work out in kilometers. Okay. Now the same distance situation, we get S1 T1 equals S2 T2. So that's what we're going to use. So S1 T1 equals S2 T2, right? So we get 8T plus 8 into 1.5 is 12, and this equals 12T, right? So if I bring 8T to the right hand side, it gets subtracted from 12T and I get 4T on the right hand side equals 12, which is what is left on the left hand side. So T is 12 divided by 4, 3, right? So B is covering this distance in 3 hours. So if B is covering D in 3 hours, then D must be speed into time, which is 12 into 3 equals 36 kilometers. All right, now this question is a slightly more complicated question. What I suggest is you pause the video and take your time, try to solve it, and then we'll then listen to the discussion. Okay, hope you've read the question. Now let's start the discussion. If you notice here, what is happening is that the train is traveling a certain distance at a certain speed, right? And the time it takes is a certain time. So we don't know none of these variables. Okay, so let's start with describing the usual situation where the train is covering a distance d at, let's say, a uniform speed of s and taking time t, right? Now in this sentence, from here to here, there is another situation described where, so I'm describing this as special situation, or let's call it situation 2. So in situation 2, what is happening is the train still must cover the same distance. Yeah. However, the train is traveling 6 kilometers per hour faster than the usual speed. Yeah. And the time that it takes, right, to still cover the D is it reaches 4 hours ahead of scheduled time, which means that it has taken 4 hours less than T, right? Now you notice that in both these situations D is same, so we get S1 T1 equals S2 T2. So let me just combine both of these. So S1 T1 equals S2 T2, right? So when I simplify this, I get ST equals, let's open these brackets up. I'll multiply S with T minus 4 to get ST minus 4S, and then I'll multiply 6 with T minus 4 to get 6T minus 24, right? The ST and ST cancel and we are left with 60 minus 4x minus 24 equals 0. So I'm going to just remove a factor of minus 2 from the entire equation to get, so I'm dividing the whole thing by minus 2 to get 2s minus 3t plus 12 equals 0, right? So this is the first equation that I get. Now let's look at this statement, right, which describes and actually describes a third situation for me, right, where what is happening is that the train is still covering the distance d, yeah, however this time it is traveling at 6 kilometers per hour slower than the usual speed, right? So the speed this time becomes s minus 6. Okay, now if the speed is s minus 6, the train takes 6 hours more than the scheduled time, right? So that it takes t plus 6 hours, right? So again we have, if we look at the usual situation and the third situation, again we have two situations where d is the same. So s1 t1 should be equal to s2 t2, just like I did previously, right? So this time what I'm going to do is I'm going to combine this statement and this statement, right, to get s into t. So let me just draw a line here. So we get s into t, which is s1 t1 of the first situation, the usual situation, equals s2 t2, which is s minus 6 times t plus 6, right? So again st equals, let's open these brackets up, s multiplied by t plus 6, I get st plus 6s, and minus 6 multiplied by t plus 6, I get minus 6t minus 36, right? Again st and st cancel, and this time I can divide the whole equation by 6 to get s minus t minus 6 equals 0, right? So if you want to pause the video again and take a couple of minutes to solve these two linear equations, you will come up with the solution that s minus t equals 6, s is 30, right, and t is 24. Okay, so if you solve these, this is what you're going to get. 30 minus 24, 30 minus 24 being 6, and 2 times 24 minus 2 times 30 minus 3 times 24 plus 12 is going to be also 0, right? So this is what you get. Now if the speed you get is 30 kilometers per hour, the usual speed, and the usual time that the train takes is 24 kilometers per hour, the length of the journey d is just simply going to be s times t, which is 30 times 24, which equals 720 kilometers, right? So that's your answer, answer B. Now this question is going to be slightly confusing. You want to take a minute to read the question and then return to the discussion. Okay, so the discussion here goes, you notice that what is happening is that a person is going from his home to the shopping mall, spending 35 minutes there and then returning, right? And for the different speeds that he takes, the only thing we know is the ending point, right? The ending points of his journey, right? Now what confuses the matters further is that this man is spending 35 minutes at the mall, right? So this complicates, it would seem to complicate our discussion here, but really if you think about it, this 35 minutes spent in shopping, it does not really matter to the travel time, the walking time from home to the shopping mall and from shopping mall to back home, right? Because you can take 35 minutes in all the situations, or you can take 40 minutes in all the situations, or you can take 1 hour in all the situations. The only thing that will change is the starting time, right? Which is not what we are bothered here. What it will not have an impact on is the travel time, right? So basically, if I were to simplify these three situations, yeah, the distance from home to the shopping mall remains d, right, in all the three situations. But in the first situation, right? Let's say he covers this distance, the to and back distance, in at a speed of 10 kilometers per hour, right, and takes time t. Okay, now what is happening is that in the second situation he still covers this distance d. He covers it faster. This time he walks at 15 kilometers per hour, right? But this time what happens is that instead of arriving home at 1900 hours, he arrives at 1830 hours, which is half an hour faster, half an hour lesser than the travel time in the previous case, right? So this speed, the increase in speed, is shaving off half an hour of his travel time. So that is all we need to do. I've taken it half an hour because the time is in hours. Okay, the speed is also is in kilometers per hour. So in the second situation, when he walks at 15 kilometers per hour, the travel time is reduced by half an hour. Now to the question says that if the same distance must be covered in a time which is 45 minutes faster than the usual time, right? So 1815 means 45 minutes less than his usual time, which means that the question is what really the question is asking you for is, at what speed should this person walk to arrive 45 minutes earlier, right? And 45 minutes is really 3/4 of an hour, right? So we are talking about these three situations, right? So again, just like the previous question, because the D's are all the same, we are going to use S1 T1 equals S2 T2. So the first equation is S1 T1 equals S2 T2, right? And the second equation becomes S1 T1 equals S3 T3, right? So from the first equation we can easily solve for t. We get 10t here, we got 15t here, and we got 15 by 2, right? So what I'm going to do is I'm going to take 15 by 2 negative to the left hand side, right? And I'm going to take 10t here to the right hand side. So 15t minus 10t becomes 5t, right? So I get t equals 15 by 5 to the 10, which is equal to 3 by 2, right? So the usual travel time is 3 by 2 hours, which is 1.5 hours. Okay, and if I were to put the value of t in here, I should be able to find the value of x also, right? So I got 10 times 3 by 2 equals x into 3 by 2 minus 3 by 4, right? Which is actually 6 by 4. So 6 by 4 minus 3 by 4 is 3 by 4. X times 3 by 4, right? So let's cross multiply. We get x equals 10 into 3 by 2. This was the left hand side, and I'll take 3 by 4 to the other side. It will become 4 by 3, right? So I cancel 3. This is 2 times 2. So x is 20 kilometers per hour, which is the answer. Thanks for watching the video. You can give your feedback in the comments section below. Please click the like button if you thought the video was helpful. For lesson updates, you may subscribe to my YouTube channel People Plus, or you may read my blogs at peopleprep.com, or you can directly connect to us through our Facebook page @PeoplePlus, or you can email to me at gagan@peopleplus.com. Thank you.